Everyone, welcome back to the channel. In today's video, we are diving deep into one of the most powerful and underrated cluster algorithm in machine learning, that is DBSCAN, or density-based spatial clustering of application with noise. You may have heard of k-means or hierarchical clustering, which we discussed in last video, but DBSCAN is in a league of its own when it's come to dealing with complex dataset with noisy data. So unlike k-means, DBSCAN does not require you to predefine the number of clusters, and it can identify clusters of the arbitrary shape. So in this video, we'll explore DBSCAN works and then walk through a Python implementation on a more complex dataset than a typical IRIS dataset. And we'll analyze the results together. So let's get started. First thing first, what is DBSCAN? So DBSCAN groups point based on their density. So in simple term, it says that the points that are closely packed together belongs to the same cluster, while points that are far apart or into low density region are considered outlier. So the algorithms uses the two key parameter, the epsilon and the min points. So epsilon, this is the maximum distance between 2 points for one to be considered as the neighbor of the others. And the min points, this is the minimum number of points required to form a dense region. Also, the points is based on three categories. So the first is the core point. So point that have at least many points with an epsilon radius. Second is the border points, point that are within the epsilon region of a core points, but do not have enough neighbor to be a core point themselves. And the third one is the noise points. So points that are neither core point nor border points. Now let's move to the implementation and we'll set up our environment. So make sure you have the NumPy, Matplotlib, and scikit-learn libraries. So I will install these libraries or import those libraries. Now let's talk about the dataset. We'll be using, instead of the iris dataset, we are going to work with more complex dataset, the make blob dataset, and which we will add a noise to. So we are generating a blob of the dataset that form three distinct clusters. Actually four, and we will also throw in some noise that has the DBSCAN ability to detect outlier. So let's create the dataset, and now let's also add the noise. Let's standardize the RX data, and now let's visualize the dataset. So this is the dataset with the noise, right? And now let's apply the DBSCAN to this dataset and see how well it performs. So we'll use the DBSCAN class from the scikit-learn. Right, let me load that. And here I'm using the epsilon as 0.2 and medium sample as 20. So the epsilon defines how close must be to each other to be considered the same neighbor. And we have also minimum sample 20, meaning that the cluster must have at least 20 points to be considered a valid cluster. So let's visualize our results. Great. So here's our result, and you notice that DBSCAN has correctly identified the main clusters, and the points that are far away from any dense region are marked as the noise. Now, notice how DBSCAN does not require us to specify the number of clusters in advance. So unlike k-mean, instead, DBSCAN uses the density of a point to automatically find the cluster of arbitrary. Let's take a moment to talk about the tuning the parameter. So choosing the right epsilon and the minimum sample value is crucial to get the good result with DBSCAN. So if epsilon is Too large, DBSCAN may merge multiple clusters into one. And if it is too small, so DBSCAN may treat points as noise. So similarly, the minimum sample will make DBSCAN less sensitive to smaller cluster, while decreasing it make it more sensitive and prone to noise. So to wrap things up, DBSCAN is powerful clustering algorithm that's an excellent for handling noisy data and detecting cluster of arbitrage shape. Remember, choosing the right epsilon and minimum sample values is key to its success, and it can be a bit of art to find this right balance. So key takeaways, DBSCAN does not require you to predefine the number of the clusters. It can identify cluster of any shapes. It's a robust to noise and outlier. So if you want to explore more advanced topic concept like DBSCAN performance on higher dimensional data or other clustering problem, let me know in the comments below. Thank you for watching. I will see you in the next one.